step and also write down the equations with the replaced Cartesian points, right? So then I'm asking you a more general question. Do you understand how we work with these LP problems, how we create the graph, how we understand what the feasible region is, how we replace the values, and how we create the minimum or the maximum of the function? Yes? Perfect. Okay, perfect. Okay, then let's see. We have time for one more exercise. We always have time for one more exercise. So let's find one that would be really, really good. Okay, we're gonna do 2 more exercises that are more theory-based, but I still feel like we should go through them. And I would like us to do exercises 8 and 9 together now. So we'll read it. By the way, a more practical question, but this is right? Yes. I definitely think so. I think it's held on Canvas, it's proctored. I don't think you can take it in the campus. I'm not actually sure, but yes, definitely digital. So it's going to be in the exact format that you had on Canvas with these types of answers where you choose and so on. So it should be like that. No worries. Let's see question 8. A business master program consists of 2 years of courses. Of all first-year students, 10% remain first-year students, 70% become second-year students, and 20% drop out. Furthermore, 30% of second-year students remain second-year students, 60% of them graduate, and 10% of them drop out. This is our partial transition matrix that they have already created for us. And it consists of 4 columns of probabilities, and it's a 4x4 matrix, right? In which they have included these percentages of what happens throughout the years with our percentage of students. Let's explain a little bit the matrix first. So how they created this transition matrix. You're usually not required to create it, but we should understand it. So each column represents one stage in a business master students program. First column is first year of masters, second column is second year of masters. Afterwards, we have a year after masters, 2 years after masters. This is why we have 4 columns. And all of these information, the 4 lines, represent certain percentages of the possibilities of what could happen with you during or after your master's program. How? First year students, so first column, 10% remain first year students. So the first line of the matrix represents the number of people who have to repeat the year, the first year. So 0.1. The second line will represent 70% become second year students. So these are people who are second year students or who remain second year students. Therefore, here we would be missing this percentage of 0.7. The third line would represent the percentage of people who graduate, and the fourth line, the percentage of people who drop out. From the first year, nobody can graduate. That's why we have a 0 here. And the 20% dropout rate is indicated through the 0.2 on the last line of the transition matrix. So this is what the first column represents. When we transition it into the second column, we read it as how many people have remained first year students in the second year? That's 0. It's impossible. You cannot be a first year student in the second year. Therefore, the first element is 0. However, we know that out of the 100% people who are in the second year, 30% remain second year students. Remember that this is connected to the fact that 70% become second year students. Okay, so this is the second year student line. 30% of them remain second year students. 60% of the second year students graduate and only 10% drop out. What happens in the next stage of their lives? Well, again, they cannot remain first year students when they have graduated university. They cannot remain second year students when they have graduated university. Here, is the percentage of graduation, which after a year of the master's should become 100%, because everybody should have graduated at this stage in their lives. That's why they have a 0% dropout rate. The fourth column, on the other hand, describes the fact that this is the final state of your matrix, where you have 0, 0, 0, and the percentage of 100% for the people who have imaginarily dropped out because they are not in the master's program anymore. That's what it represents. This is how we read the transition matrix. Again, some information that you don't necessarily need in order to create it, but you should understand what it means. If this is still a little bit confusing, remind me that after class I will send you a sheet of paper with some more explanation on how you read this matrix. But please remind me because I tend to forget. Okay. So if this is the partial transition matrix, what values are missing? Here we already established that the 0.7 is missing from the 70% of students who become second-year students. And here, the value 1 is missing. We didn't even need to know all of this information about the matrix in order to deduct that here is missing the value 1, because we know that in the transition matrix, the sum of the elements on each column should be equal to 1 because it represents a percentage. Therefore, the answer should be 0, 7, and 1, because here the summation of all of this information should be equal to 1, the same as those on the second column, same on the third column, the same on the fourth column. So this is how we would solve exercise 8. Because again, we have the condition that each one of the columns should in total have a summation of elements equal to 1. This is some theory from Markov chains. So if you don't understand why they have to be equal to 1, go again through the theory a little bit, because you should understand that this is a transition matrix which describes probabilities, probability states, okay? So that's kind of it for exercise 8. Exercise 9. We have the same exercise as before with our business master's program, which consists of 2 years of courses and all of this information about our percentages of how probabilities change over time. If the transition matrix has a size 4 by 4, therefore 16 entries, which of the following options is not true? So a little bit of theory, but I want to make sure that everybody understands. Can everybody tell me, pretending this is A, B, C, and D, which of these options is not true? Can you please write in the chat? I'm going to give you guys a few more seconds, like 30 more seconds to think, write your answer in the chat, and then we'll explain each one of them. Okay. So the correct answer, the option that is not true, is option D. The Markov chain is defined by 4 time points. Let's see why. We'll go through them step by step. The Markov chain has 4 states. Yes, it does. 4 states because it contains 4 columns, 4 lines. Therefore, it has 4 states. The sum of all entries of the matrix should equal 4. Well, that's true. Remember that in the Markov chain, each one of the columns should be in total summated to a 1 because it represents 100%. Therefore, the total summation of the entries should be 1 plus 1 plus 1 plus 1, which should be equal to 4. Therefore, B is also correct. The steady state vector has exactly 4 entries. That is correct. Remember that the steady state vector is the probability vector V, which contains 4 entries. defining 4 probabilities in time. It has 4 entries because it's a one column with 4 lines, 4 entries. The only one that is not correct, that is not true, is the Markov chain is defined by 4 time points. That is not true. We don't know by how many time points is defined this Markov chain because we are not being told how many V vectors we have. The vector V, remember, it was called the probability vector V, which described by its indice t the time point to which our Markov chain has reached. That V goes from 0, which is the initial state, until V1, V2, Vn, which represent n, and that n of the vector represents the time point in which we are with our matrix. So this is why this is the only option that is not true. All of the others are true. Is this clear for everybody why these 3 are true and this is not? It's a little bit of theory, I know, but do you understand now that I've explained? Yes? Okay, great. And I think that's amazingly, okay, we did amazingly because we are exactly on time and I finished everything that I thought I wanted to do with you guys during this crash course. So now before we officially end this meeting, if you give me 5 more minutes of your time, I would like to tell you a little bit about what's going to happen now after the crash course and what your expectations should be of what I'm going to do after we officially end this meeting. So first of all, I would like to thank you all very, very much for participating. And as always, with all of the Athena crash courses, please don't forget to fill in the evaluation form that you will receive in your email after I will officially end this meeting. It's really important for me because it helps me improve as a teacher, and it also helps us at Athena improve our teaching style and try to understand what you guys need because you are our target group, right? That being said, I wish you all a lot of good luck with your exam. I will give you a few hints and points of what I think would be the best strategies for you right now to take if you feel like you're still struggling a little with the material. I'm going to send you everything I have, every picture of every exercise that we've done. I'm going to send you the PowerPoint presentation, and you already have the booklets from Athena Summary that you can use for studying. What I suggest you do is take one more day to go through the theory that we've organized together here. Try to read everything carefully, try to understand the algorithms, and most importantly, try to practice on your own. Another very important thing, don't panic if you're doing exercises and cannot get the correct answer from the very beginning. That's completely fine. It happens to everybody, and it should not be a reason for you to panic. If you feel like you're mastering most of the material and there is one small little chapter or one sub-chapter that you feel like you're not completely understanding, don't worry and spend too much time working on that, stressing yourself out. Try to work equal amounts of exercises from each chapter, because every time you will improve your knowledge little by little from the sub-chapter or chapter or part of the exercise that you still don't know how to understand or how to work with. That being said, that's why we have the WhatsApp group. And that's why I am there, your teacher, to help you out and help you understand these exercises further. Please try to practice as much as possible. Try to do the entire exam paper of 2018, 2019. I don't know how many they're posted or which ones are posted. Try to work them. And whenever you have questions, please address them on the group. I have solved the exams already, and I have some pieces of paper with the exercises explained. So whenever you have a question, I can send you my own results, but I can also help you out with a message, with an extra explanation, with maybe another photo of some other piece of theory that maybe I have missed in that moment from the slides, or maybe I can point you toward a chapter in the book that would be really helpful for you to understand. So that's why I'm there. So please make use of me, because that's why I'm here to help you pass your exam. Okay. That being said, we're officially done. Thank you all so much for joining, and I hope you found this crash course useful and also entertaining. I hope you didn't get too bored, because I know 4 hours in one day is a lot. However, it's the less cruel of the alternatives, rather than dividing the crash course into a lot of days. Again, thank you so much for joining. Have an amazing rest of the day. Try to take an hour or two of break, eat something, feel well, go for a walk, and then start doing your exercises again if you feel like you need to practice because you've already done a lot. 4 hours in the morning is a lot. And yes, thank you so much, guys. And I hope I will not have to see you again. Thank you so much for joining. Bye-bye.